Okay, I think we can get us started. Hey, everyone. Welcome to the last CIIR talk of 2024. This is my pleasure to introduce Zhaochun Ren from Leiden University. He's an associate professor there. He's working on information retrieval and natural language processing with an emphasis on conversational AI, recommender systems, and conversational AR. His goal is to develop intelligent agents that can address complex user requests and solve core challenging problems in information access. And he has received multiple awards from multiple major conferences, such as Rexus, Sequoia Wisdom, and so on and so forth. Please join me in welcoming Zhaochun to UMass virtually with a round of applause. Please go ahead. Zhaochun, can you hear me?
Yes.
Please go ahead.
Okay, so all right, so good afternoon, everyone. So it's my honor to be invited to give a presentation about to introduce our recent study about empathetic conversational recommender system. So my talk is based on joint work with my colleagues and my students. Including my students in Leiden and also my students when I was working in Shandong University. So my today's talk will be included into 3 parts. So knowledge enhanced conversational recommender system, and then I will briefly introduce the empathetic dialogue system, and lastly, I will introduce the SOTA study about empathetic conversational recommender system. So the first part is about the knowledge enhanced conversational recommender system. Okay, so let me briefly introduce several preliminary about the conversational recommender system. So I think maybe many of you heard of that, but some just for someone who's not so familiar with this topic. So traditional recommender system primarily predict the user preference towards an item by analyzing limited type of behaviors, for example, user click behaviors or item ratings. And this type of interaction modeling fundamentally limited the way in which user intention can be expressed to some extent. So the emergence of the conversational recommender system, or abbreviated as the CIIR, has revolutionized how we interact with the traditional recommendations. So the task of the conversational recommendation has been proposed to provide recommendation to users through the multi-turn conversational interaction in the neutral language way. And by interactive communication, the conversational recommender system can easily elicit the preference of the user and take actions. Existing literature in this domain is broadly classified into 2 categories. So first is focus on the attribute-aware or attribute-based conversational recommender system, as shown in the left side on the slide. So this system predominantly explore fixed response template to ask the user whether the user like a certain attribute or item, and the user can confirm or deny according to the preference. So the dialogue, as the dialogue progresses, the system regards the collected attributes or item accepted and rejected by the user as user preference, and make a recommendation to the user based on that. So the primary objective of most methodology with this category is to minimize the number of turns required to complete the recommendation task. Okay, so another category is generation-based conversational recommender system, as shown on the right side on the slide shown. So the leveraging the advances in the natural language processing, so this kind of like conversational recommender system aims to interact with the users through natural language conversation and emphasize not only the accurate recommendation, but also generate a fluent response from the recommender model. So unlike attribute-aware or attribute-based conversational recommendations, the generation-based conversational recommendation focus on making recommendation using free-form tests, which create considerable flexibility and to influence how a dialogue continues. So our work actually, or this talk is aligned with the second category, conversational recommender system. So based on an example from the benchmark datasets on the conversational recommender system, so we see a conversational recommender system can be fall into two major subtasks. So the first task is an item recommendation subtask that predict the item from a candidate set to the user based on the content of the user utterances. So researchers typically use metrics such as hit or recall or precision, F1 or NDCG or MRR to evaluate the system performance on item recommendation subtask. And another subtask of the conversational recommendation is a response generation subtask that generates the appropriate response to the user utterances in informative natural language expression. So in this task, objective metrics such as blue, rouge, or perplexity, and the subjective metrics from the user annotation as fluency or informativeness are often used in the evaluation of this subtask. So here is quite a one of the main challenges of the conversational recommender system is the lack of sufficient contextual information for accurately modeling user preference and generating persuasive response. So meanwhile, to complete these two tasks, existing methods usually set up two separate modules for each subtask. So there might be semantic inconsistency between the two modules. And the incorporation of the shared useful knowledge can be used to strengthen the connection between these two modules and enrich the dialogue context for predict user preference and generate informative response. So we can dive into recent advance in this realm of the knowledge enhanced of the conversational recommender system. So first, we need to answer a foundational question, and so from which what data source can we access knowledge? So in this talk, I categorize the knowledge source into the following three categories. So first is mining in context knowledge, and second is incorporate external knowledge graph, and the third one is use language model or pre-trained language model or large language model. So I will share several insights from our recent research that bolsters the recommendation quality and the richness of the conversational response based on each type of these knowledge source. Okay, let's move to the mining in test knowledge refers to using the knowledge reflected in the user natural language interaction with the system, which is in context content in the dialogues. So in our I will use the example, use our proposed method in the CIIR 2022 as an example to demonstrate this part of the knowledge that can be used for the conversational recommender system. So we utilize cross-session in-test knowledge in this work. So there are two challenges to motivate our study. So first is items or entities in context only reflect part of knowledge, information shared in conversation. They are not enough to fully capture the user preference in conversational recommendation, and in some cases, they may instead introduce noise and make the recommendation results quite opposite to the user preference. And the second challenge is the conversation can only reflect user short-term preference. For example, user preference expressed through a few rounds of the Q&A between the user and the recommender, and cannot express user long-term preference, such as user preference mined from the user item that the user frequently click or purchase. So based on that, we propose UPCR as a model name in this work. So to formulate the problem. So in round T, in this work, the input of the model consists of the users, conversation context, and the entity plus. So where the context and the sentences connected from the previous T-1 round corresponds to the context. And the entity plus is entities discussed in the context connected in order. So based on the input, we track the user's long-term and short-term preference, which we consider as two hidden variables in the Bayesian generative model. And based on the user preference, we output the item to be recommended based on recommendation, and we generated replies to recommend this item to the user and explain the response, the reasons for recommendation. So in detail, actually, so the UPCR comprise four processes. So first is about the input representation. So we use the transformer encoder to encode the various input, and then we move to the second part is the preference explorer, based on this long-term preference and the short-term preference prediction. So by using these two separate explorers to track the both long-term and short-term user preference, the short, I mean, for this user preference is updating during the conversation or through multiple conversation sessions. And then we move to the policy network, which is to predict the item to be recommended based on the user preference. And lastly is the response generation, which is also based on the transformer decoder to generate the response based on that, all the policy predicted. I use this example to this table to show the results that we UPCR achieved in the experiments, which can be found that the UPCR achieved quite great results on the benchmark datasets. So we can see that it's improved in the almost over 20% for all in terms of four metrics like NDCG 10, NDCG 15, MR, and respectively, compared with the SOTA baselines at that time. And also we can see that the similar on another data sets, the retail data sets is also can get a comparable improvement over baselines. So this time shows that the comparison of the effect of the generation subtask on this on the data sets, and we can also see there is a clear significant improvement over the baselines. So the proposed method performs frequently diverse and informative reply since it's considered the user ID, context, entity, path, and recommendation, which can be shown reflected not only in terms of the automatic evaluation metric, but also the subjective, like a human annotation. So next, let me come to introduce how to incorporate the external knowledge graph to enhance the performance of the conversational recommender system. So which can be found in our paper published at the CIIR at Wisdom 2023. So as shown in this some early study in the 2019, namely KBRD, so a major limitation of end-to-end conversational recommender system is that the only item mentioned in the training corpus has a chance of being recommended. Since items that have never been mentioned are not modeled by the end-to-end model, so the performance of these methods is greatly limited by the quality of the human recommendation in the training data. So to overcome this problem, there is in the KBRD methods, all those incorporate the domain knowledge graph in this work which is from knowledge from the DBpedia to assist the recommendation and the generation system by providing sufficient knowledge or background information to enhance the understanding of the user semantics. However, there are several challenges in the conversational recommender system incorporating such a kind of external knowledge graph. So based on that, we present a work at Wisdom, which try to solve this problem by deeply integrated external knowledge graph and in-test knowledge. So first, original knowledge graph that employed in existing conversational recommender system are often incomplete and sparse, which limited the reasoning ability in recommendation. So we can see an example on the slides of about a conversational recommendation on the left so the solid line indicates the relation exists in this original knowledge graph. So while the bottom half of the graph form an independent subgraph without the entity, in this example, the dark night, which demonstrates the interaction one as the target entity cannot be inferred. But we see that the missing relation between the Dark Knight movie and the DC Comics can be explicitly completed by incorporating the dialogue corpus, which can be reused for interaction one. So besides, only few of the existing study explore the dialogue system, the content to dynamically refine the knowledge from knowledge graph for better recommendation. So they simply utilize entire knowledge graph for various interactions. So for interaction 1 and interaction 2 on the slide, we can see correct knowledge should be selected conditioned on the corresponding dialogue context, although both of them mentioned the Wonder Woman. Okay, so in this work, we propose a versional reasoning knowledge model over incomplete knowledge graph conversational recommender system. So which is abbreviated as a VRICR. So to overcome the above limitation we given in our last slide. So given the original knowledge graph and the dialogue context, our key idea is to incorporate the large dialogue corpus neutrally accompanied with conversational recommendation to enhance the original incomplete knowledge graph and perform dynamic knowledge reasoning conditioned on the dialogue context and select relevant knowledge. So however, it is still an open question in an unsupervised paradigm to do such a kind of process. So which drove us to adopt a versional Bayesian method in this work. So specifically, we denote the dialogue-specific subgraph of knowledge graph as a discrete latent variables in our model. And due to the fact that the original knowledge graph is incomplete, so it leverages a dialogue corpus for explicitly reconstructing missing but useful knowledge relations. So besides, dialogue-specific subgraph dynamically and adaptively retain correlated entities and relations in the original knowledge graph based on the knowledge context to perform adaptive knowledge reasoning. So finally, we infuse this dialogue-specific subgraph to decode the target recommendation and generate the response. Okay, so here is an overview about our proposed model in this work. So we frame our model as four main components. So first is a context encoder, which use a BERT to encode the various input, and then is about the knowledge graph in refractor network. So in this part, we formulate a relation refractor as a classification task, and we design approximate posterior and prior knowledge graph refractor network based on the multi-layer perception to determine whether there is a link between entity pair and which correlated link to retain in the same time. And third is about the recommender which to learn and enhance the user representation from the derived dialogue specific subgraph and predict the item to be recommended. And then it's the response generator, which take the dialogue context and derive the dialogue specific subgraph as the input. A knowledge enhanced transformer decoder then is employed to generate the response. Okay, so this is let me briefly introduce the third part, which about the emergent research trajectory with this domain emphasis, the synergy between conversational recommender system and the large language models. So I will use our recent study post Mars that's as an example to show that how can we apply a larger model into a multi-agent conversational recommender system framework. The language model, not only the large language model, but also some pre-trained language model has been based on the large data sets acquire a parameterized knowledge which enhanced ability in the language generation and in context understanding. So this strong ability can lead many researchers to utilize the pre-trained language model in conversational recommender system. So there are two representative studies about using a pre-trained language model for the conversational recommender system. So first is RIDE. So RID is a conversational recommender system framework that's based on the pre-trained language model and is fine-tuned the large scale pre-trained language model such as dialogue GPT together with a pre-trained relation graph convolutional neural network to fuse a knowledge graph. So that it can integrate the knowledge graph into this response generation. And another one is a BICO, which is a unified conversational recommender system based on the bot, and it's handle both dialogue task and the recommendation task using a single model. So there are bidirectional encoder of the pre-trained language model in this BICO model, which serve as a recommender. And also there is the other set up autoregressive decoder as a response generator. Now we have a large language model. So in the era of the large language model, these pre-trained language model integration, the integration of the pre-trained language model in with conversational recommender system made quite insightful direction. So due to their common sense reasoning ability and the extensive parameterized knowledge embedded in these large language models, so these kind of methods will significantly boost the system personalization and user interaction and making the recommendation more contextually relevant. So the conversational recommender system with large language model has recently received an increasing number of attention. So however, the technology to seamlessly blend the large language model with conversational recommendation is still evolving. So the question is, how can we develop this integration to unlock the full potential of the large language model to the conversational recommender system? So existing conversational recommender system with large language model generally follow two paradigms. So first is a large language model with external recommendation. So this for this paradigm, the recommender system conducted the recommendation task, and the large language model conducted the dialogue, the response generation task. Another part is so-called large language model only paradigm. So in this paradigm, the large language model conduct both recommendation task and the dialogue system. So for the large language model with external recommender system paradigm, some researchers proposed several methods recently. So first is about the about the interact agent, so which is a large language model based agent to employ large language model as a brain and the recommendation model as a tools. So the large language model will determine whether the current conversational necessities and the assistance of tools, including circle or recommender system. And firstly, so based on the user needs, a set of candidate item will be retrieved using circle queries. Sequentially, the candidate item will be ranked using the recommender system. And finally, the resulting recommendation will be returned to the language models for the response generation. And another one is named large language model CRS, so LLM CRS. So it's collaborated large language model with several expert model of different conversational recommender system subtask. And the conversational recommender system subtask include the user preference elicitation, recommendation, explanation, item information search. And the language model are responsible for managing the expert models and generate the final response based on the output of these expert models. So in the recommendation and the dialogue task, the previous paradigms rely on the distinct modules, and this module is really difficult to share useful information, consequently having information gap between them. So in contrast, the large language model only conversational recommender system can share useful information between the recommendation task and the dialogue system task, or the response generation task. So the large language model can serve as a zero-shot conversational recommender system, which primarily uses supra context and context knowledge to make a recommendation. So in our recently proposed methods, we utilize the large model as the agent for conversational recommender system. So the large model only conversational recommender system needs to fulfill both the recommendation task and the dialogue task. So it's typically contain various dialogue acts such as chit chat, recommendation, and asking. So the chit chat is can enhance the user interest in interact with conversational recommendation, and also can be can demonstrate the user preference like a real salesperson. Like a real salesperson. So, and the recommendation act like can provide item to user in natural language form, and the asking act can actively elicit the user preference. So, because of the large language model, the conversational recommendation generally has a clear defined target and the goal to recommend a specific item to a user. So, an engaging conversational recommender system with large model should be able to control the dialogue flow, which means it can choose the proper dialogue act at each turn. So however, previous work shows that the ability of the larger model to control the target directed dialogue flow remains limited. For this reason, single agent is hard to control the dialogue flow, leading to generating low efficiency dialogue. So for some complicated tasks that the single larger model-based agent may struggle to accomplish, so researchers propose breaking them into multiple simple subtasks and then having multiple large language model-based agent to collaborate to jointly complete the whole task. So similarly, conversational recommender system is also typical. It's typically to complex task involving various intricate dialogue acts. So inspired by this multi-agent approach studied before, so we propose to design a collaborative multi-agent framework to enhance the dialogue act planning. So the characteristics of the conversational recommender system is users and the system can engage into multi-turn interaction. So during this process, user can provide user feedback according to the system response. And the user can actively clarify their preference in their feedback. And this feedback also encompasses their satisfaction with recommendation results. So as a result, this informative feedback not only allows the system to obtain more user information, but also reflect the reason why the recommendation failed before. So we believe that this feedback can be used to dynamically optimize the system during the interaction, but this aspect has been overlooked in previous study. So to address this above issue, so in this work, we propose a multi-agent conversational recommender system framework, which is a large language model only conversational recommendation that can efficiently plan and dynamically refine the dialogue and the recommendation. And the figure shown on the slide is an example about modeling in this multi-agent conversational recommender system. So the right side shows a dialogue between the conversational recommendation and the user, while the left side depicted the internal framework of the proposed method. So we see the responder agent and the planner agent collaboratively generate the approach response, and while the reflection the reflection mechanism provide the feedback and refine the guideline to this agent, which optimize their response to better satisfy user need. So the proposed method is composed of two essential modules. So first is about the multi-agent act planning, which is a collaborative large language model-based multi-agent framework to effectively plan the dialogue flow by selecting suitable dialogue act for each turn. And the second module is the user feedback aware reflection, which is a dynamic optimization mechanism based on the large language model. The multi-agent act planning module is composed of three responder agent and one planner agent. So each responder agent is tasked with performing a dialogue act and generating a candidate response based on its assigned rule. The asking responder agent focus on posting questions to the user to elicit the user preference, and the recommendation responder agent present item to the user that predict that user may be interested in, and then to enhance the user experience or satisfaction or try to or engagement with interacting with the conversational recommendation. So it's also important not to repeatedly recommend items and ask questions. Instead, timely chit chat with the users about items is facilitated by the chit chatting response. Responder agent is also quite important. So this Carol conversation can bolster user engagement with the conversational recommender system. So after getting various candidate response, the planner agent engage into multi-step reasoning to choose appropriate dialogue act, and the planner agent will take into account three key considerations. And the second module in our proposed framework is about the user feedback aware reflection mechanism, so which use valuable user feedback to dynamically optimize the agent. So this mechanism operated at two levels, information level and the strategy level. The information level reflection refers the user preference from the user feedback and summarize them as the user profiles. So here, the user profile contains the current user demand and browsing browsing history, and then transmitted to the memory module of each responder agent. So which will help the responder agent to effectively capture the user preference and also remind them to avoid generating duplicate content. For the recommendation, for the evaluation to assess the effectiveness of our proposed methods in both response generation flow and the recommendation flow, we conduct experiments using the user simulator. So the user simulator engage in multiple tens of interaction with the conversational recommender system. So once the maximal dialogue tens are reached, the conversational recommender system directly generate a list of recommendation. And then we evaluated the success rate of the dialogue samples and also the hit ratio of the recommendation list to validate the recommendation accuracy. And additionally, we use the success rate ratio and the average tens to evaluate the dialogue flow of the conversational recommendation. So the experimental results demonstrate the advantage of our proposed methods in terms of the recommendation accuracy and the efficiency of the dialogue act planning. So here is several case studies. We provide examples of dialogue between the user and both proposed multi-agent framework and the baseline methods. From this example, we can observe that the ChatGPT fails to recommend the appropriate item to the user, as it does not dive deeper into the user preference in the second turn. So unlike the ChatGPT performance, the proposed multi-agent framework is able to discern and is implicit user preference when the user express dissatisfaction with the director, which enable the proposed method to better steer the dialogue and then eventually make a successful recommendation. Okay, so this is some previous study or recent study about the knowledge enhanced conversational recommendation. So before I introduce our recent study towards empathetic conversational recommendation, let me briefly introduce the empathetic dialogue system. So to further enhance the user experience in the conversational recommender system, so we focus on the user emotion states and explore the empathetic dialogue response generation task. So that this task aims to accurately comprehend the user emotion and then generate appropriate user response. So because emotions is quite complicated, so normally the AI system, conversational AI system struggle to accurately perceive the user feelings by analyzing dialogue along without additional knowledge. So to perceive the emotion precisely, we utilize additional knowledge to enhance the emotion understanding in dialogues. The primary challenge here we face is in improving the model emotional perception is how to use external knowledge to enhance the system empathetic capabilities. So we propose a multi-resolution adversarial empathetic dialogue generation model, which operated the IMP-DG in the coding 2020. So in this work, we employ an emotion dictionary to enhance the word-level emotional perception and expression in dialogues, so preliminary exploring the use of the external knowledge in empathetic dialogues. So let me first introduce several motivation of this task. So first, about the previous methods focus on, especially for the emotional dialogues, only on the dialogue level emotion. As shown in this figure, we see the speaker describes the sister obtaining a new job, expressing the emotion of proud. However, existing approach only captures the overall proud emotion, but negative nuanced emotion within the phrase like a new job. So, and then it failed to comprehensively understand the speaker's emotion state. And second, additionally, so this previous study overlooked the emotional feedback from the dialogue participants, which could further refine the emotional identification. So to address this limitation, we introduced multi-resolution adversarial empathetic dialogue system based on the GAN strategy. So the methods primarily extract the speaker emotion word from dialogue using an external dictionary and then focus on a refined nuanced emotion. So we use both automatic evaluation matrix and human annotation subjective evaluation matrix to evaluate the performance. So the objective evaluation matrix or automatic evaluation mainly mainly demonstrate the proposed model's performance, mainly evaluate the emotion accuracy, diversity, validating the effectiveness of integrating word-level emotion words. So the model's perplexity scores was slightly slower than previous study, but this can be attributed to the introduced interactive discriminator, which prioritized the emotional accuracy and the response diversity, potentially at the expense of the linguistic fluency. For the human evaluation, we evaluated the response, empathy, relevance, and fluency. These results align with automatic evaluation results and also which demonstrated the significant enhancement in empathy and relevance. So in our previous methods, we enhanced the explicit emotion perception using external knowledge. And then based on that, we explored how to accurately perceive user explicit emotion through the external knowledge. So the motivation is, well, by utilizing external knowledge base to extract the explicit emotion word from dialogues can be confirmed to enhance the empathetic capability by perceiving and expressing these explicit emotions. However, the dialogue containing not only explicit emotions, but also implicit emotions, which are challenging to detect using dialogue and dialogue context alone. So, however, the dialogue content, as shown on the slide, we see the figure that in which a speaker mentions coughing blood for 3 days and fear having and the user fears having cancer. So words like afraid and cancer implicitly convey terrible emotions. So overlooking these implicit emotions might lead to the model to interpret the expression at the general level of fear rather than extremely afraid. So to accurately understand the implicit emotions, we propose knowledge-enhanced empathetic dialogue generation methods. We abbreviated the KEMP. So this method first identify entities with implicit emotion from dialogue context using two external knowledge sources, the ConceptNet knowledge graph and the VAD emotional dictionary. So and then it's construct the emotional context graph based on the identified entities. And next, we propose a graph-aware context encoder to obtain emotional representation and then emotional signals from the graph. Subsequently, we introduce an emotional dependency decoder to model the emotional dependency relations between the emotional context graph and the target empathetic response. So lastly, we through the emotional dependency decoder, our proposed model expressed more empathetic response. So we evaluate our model using both automatic and human evaluation as same as the first study on the empathetic dialogue system. And in the automatic evaluation, we assess the emotional accuracy, perplexity, and the response diversity. And the results demonstrate that our proposed model not only accurately perceive emotion, but also generate more frequent and informative response. In human evaluation, our model achieves the highest scores in the empathy and relevance, and this indicates the model's improved ability to understand the emotions and generate more contextual relevant response. Okay. Yeah, because of limited time, so I will skip the recent part about empathetic dialogue system, which published at ACL. But if you have you're interested, so you can check more details later in the slides. So let's move to the last part of my talk today. So which is about the empathetic conversational recommender system, published at RIXIS this year and also won the Best of 4 Paper award. So after briefly introducing the previous study on the knowledge-enhanced conversational recommender system and our previous study on the empathetic dialogue system, so all these previous studies on the conversational recommender system share a similar logic. So they introduce various form of external knowledge to predict the standard answer provided by benchmark datasets. But are the existing methods truly ideal for the conversational recommendation. According to the research published in the RECSYS 2011, so we found that our positive user experience is not only determined by the accuracy of the recommendation, but also by the user subjective satisfaction. So based on that, there is a question that can this be achieved with existing models? Unfortunately, according to our previous work, we found that the existing conversational recommender system model still do not fully align with user need. So these models are trained to given datasets where the presumption that the standard item and the response in the datasets are optimal leads to the tendency of the conversational recommender system to replicate the logic of the recommendation in the dataset instead of addressing user real need. So these misalignments hinder the development of the conversational recommender system. Specifically, so for item recommendations, the previous study often assumed that all these entities mentioned in the dialogue reflect the user preference, and then all the items suggested by the recommendation meet the user expectation. So, but as illustrated in this figure, we found that the previous conversational recommender system might infer that the user like Shakespeare and Midsummer Night Dream mentioned by the recommender. So, but while overlooking that the user expressing negative emotions towards them during the dialogue. So this such system makes the system recommend the wrong item to the user. So for response generation, previous studies are optimized towards standard response from the benchmark datasets. So as shown on in this figure, which is in the bottom side, we found that the response they generated to be dual and quite uninteresting, so which may diminish the user satisfaction when interacting with the system. Okay, so to explore that origin of such kind of misalignment, we analyzed widely applied benchmark datasets in the conversational recommender system, like the Riddell which is a Riddell dataset, and found the following issues. So among all the recommendation items, we see that the dislike item accounted for around 5%, and the items without a clear statement took up 14%. So not to see that entities that are mentioned but don't reflect user preference. So as for the standard response, we found that they tend to be short and lack narratives, which resulting in lack of engagement, user engagement. So existing models are trained on these benchmark datasets. So based on that, the results, so current conversational recommender systems fail in meeting actual user need. So then how can we address this misalignment? Okay, so in our work published at RECSYS this year, we first drew inspiration from the studies on empathetic dialogue generation. So all through understanding and expressing emotions is a significant challenge for all the conversational AI system due to the complexity involved. The research in social psychology suggests that the empathy is a key factor in building more human-like dialogue system. Building on our previous work on the empathetic dialogue system, as I just mentioned, introduced, we identified two inspiring psychological studies that formed the foundation concept for the method proposed in this work. So first is about the emotions are quite important in human decision-making process, and also the second is the people favor agent simulating human being are by expressing emotions. So based on that, inspired by these studies, we relook at the conversational recommender system and propose a new paradigm in this work. So we introduce empathy with a conversational recommender system to bridge the gap between the system output and the user real need. So here we define empathy as a system ability to capture and express the user and the emotions in dialogue system. So specifically for item recommendation, we capture the emotion expressed in user utterance within the dialogues to achieve accurate user preference modeling. And in response generation subtask, we adopt emotion-rich expression to elevate the user experience and contribute to the user satisfaction. So in summary, through the empathy, we aim to accurately distinguish and fulfill the user real need with a reasonable item and a persuasive response generated. Okay, to free our approach from influence of low quality benchmark datasets, we first enlarge an empathetic conversational recommender system dataset in this work. So that is more exactly match the user real need. Specifically to capture the emotion, we extract the user emotion and we mainly use large language model to discern the nuanced emotion in the dialogue history. And then to express emotion, we construct the emotional response. And so we collected top-rated emotional reviews and the informative external resource from the MDB for model training and express emotions. So these reviews are filled with genuine experience and emotions, providing rich training samples for the model. So after addressing these data issues, we redefined the problem for the conversational recommender system under the new paradigm. So given the knowledge graph and the dialogue history, our proposed methods ECR will take advantage of the user emotion labels and the emotional response, which we refers to as empathetic dialogue data to decode the recommendation and the response. So, however, implementing this paradigm introduced two technical challenges. So first, how to accurately model the user preference using emotions. And the second challenge is to generate an emotional response contributing to the user satisfaction. So in this paper, we propose an empathetic conversational recommender system so to tackle these challenges. So corresponding to the two motivations, so our proposed methods is composed of two key modules. So the emotional aware item recommendation and the emotion aligned response generation. So for the emotion aware item recommendation module, we aim to integrate user emotion with entities in the utterance to capture emotions. And for the emotion aligned response generation, we aim to fine tune a pre-trained language model to express the user emotions in the response. So this diagram provides an overview about our proposed methods workflow, which I will detail in the following few slides. Okay, so in the emotional aware item recommendation module, since the entities are important for reflecting user preference, so we aim to model the effect of the user emotion reflecting in entities. So here we extract the local and global entities from a dialogue history and the training dataset, and then we fuse this user emotion with these entities and get both local and global emotion aware entity representation. To comprehensively model the user preference with the emotion, we construct the emotional aware recommendation prompt based on these emotional aware entity representations. And then we use the prompt to fine tune a pre-trained language model to predict the recommendation item. And in the emotion aligned response generation module, our work, namely MDG that I introduced before, which published in Tooling 2020, are shown that the external knowledge enhanced dialogue understanding and expression. So in our training process, we observed that the training on large amount of the emotion data can cause semantic shifts in pre-trained language model, which leads to severe hallucination issues. So to meet the user information need to enhance emotional expression and reduce such kind of hallucination, we constructed the emotion aligned generation prompt based on retrieved knowledge from the knowledge graph and the emotional review to enhance the informativeness in the response. And to align the generation module with persuasive dialogue style and emotions during the training stage, we fine-tune a pre-trained language model as the emotion-aligned generator using the constructed knowledge emotional reviews. And during this, which are collected from the IMDb platform. So during the inference stage, we use the generator to get the emotional aligned response. So here we choose the both Dialog GPT and the Llama 2 chat as the backbone model for the emotional aligned generator. And in the experiments, considering that the traditional metrics trained by the conversational recommender system are highly dependent on the original data benchmark dataset, so that we evaluated the model in a more high-level persuasive and propose a new enhanced evaluation matrix to evaluate the user satisfaction in real-world conversational recommender system scenarios. So it comprises objective and subjective metrics to evaluate the recommendation and the generation performance. For the recommendation evaluation, besides the traditional metric like recall, we propose a new metric, recall true, which not only considers items that get positive user feedback. Additionally, we incorporate the AUC, which emphasizes the rank between items that the user like or not. And for the response generation evaluation, we moved beyond the traditional metric like blue opting instead to use 5 subjective metrics: emotional intensity, emotional persuasiveness, logic persuasiveness, informativeness, and lifelikeness. So we employ a large long model-based scholar which is based on the GPT-4 to automatically assigning scores based on specific prompt. And given inherent instability in larger models, we invite 3 human annotators to evaluate the reliability of our larger model-based scholar evaluation results. As for the baseline, we list several baseline for both the recommendation task and the generation task. So for the evaluation results for the item recommendation, we see that our model significantly outperform all the baseline, especially in the RT at 10 and RT at 50. Additionally, the proposed method demonstrated a significant lead in the AUC in terms of AUC metrics. And this finding confirms the importance of capturing user emotion in enhancing the conversational recommender system ability to accurately estimate the user preference and effectively mitigate the impact of the incorrect item labels in the benchmark dataset. And for the generation subtask evaluation results from the larger model-based scores shown that the larger model in zero-shot setting significantly outperform UniCRS, which is fine-tuned on the entire dataset. So these results indicate that the standard response in the datasets are of low quality. Moreover, our proposed Llama 2 chat-based ECR model significantly outperform all the baseline models across 5 dimensions: emotional intensity, emotional persuasiveness, logic persuasive, informativeness, and lifelikeness. So additionally, the performance of our dialogue GPT-based proposed methods are comparable to the GPT 3.5. So despite the dialogue GPT-based ECR has much fewer parameters than the GPT 3.5 tuple. So all these experimental results demonstrate that our proposed methods, by integrating the emotional reviews and knowledge graph information, can generate the response that are both emotional rich and informative, effectively enhancing the user trust and satisfaction with the system. Comparing the evaluation form from the human annotator and the larger model-based scholar, we found that the evaluation results in the emotional dimension are highly consistent, so which provide the stability of the ECR capability in expressing emotion and increasing the user emotional satisfaction. However, in contrast with the larger model-based scholar evaluation, human annotator identified that the dialogue GPT-based ECR explicit improvement over GPT 3.5 on logic persuasiveness, which is attributed to its more effective highlights on the advantage of the recommendation. So this finding suggests that even GPT-4 still has a slight gap between with the human when performing subjective task, which reconfirms the significance of the integration with the emotions and or empathy ability in the conversational recommender system to match the user real need. So we also present an example from the real dataset to demonstrate how the proposed method works in generating human-like emotional response. So we observe that the standard response rarely expresses the emotion and informative, which is hardly attractive and convincing to the user. The larger model like GPT 3.5 or Llama 7B, R27B can provide factual and logical explanations in the utterances, and in the provided examples, they try to amplify the user interest in the recommended movie by including the mentioned keyword comedy. Additionally, they often deliver a objective movie description, such as plot and the cast, where this approach could make them the results looks like quite informative and quite and logical, persuasive. But it's neglected the emotion need for the user, which make it limited in engaging the user in need. So in contrast, our proposed methods simulate the vivid conversational style between the human beings incorporating experience, subjective viewpoints, and emotions. So this strategy constructs a deeper emotion connection with the users, and indeed, the user increased the user satisfaction, and so it's also maintained the high quality factual information to support the emotion reasoning and highlight the strengths of the movie. So even in the logical persuasiveness and the informativeness are areas where the larger model traditionally still, so our proposed method still retain the quite highly competitive. So let me wrap up my talk today. So what I talk about is to address several questions. The first is I introduce I try to answer why do conversational recommender systems need knowledge. So in this talk, I analyze why I introduced the conversational recommender system mainly aim to provide recommendations through real-time multi-turn natural language interactions. However, this previous study faced challenges in maintaining the user expectation during the lack of sufficient context information and the semantic inconsistency between the recommendation task and the generation subtask. So incorporating knowledge is highlighted as a solution, an effective solution to address these challenges in the conversational recommendation. And secondly, we discussed the source knowledge in the conversational recommender system, which highlight three key aspects. So first is about mining in-test knowledge, where the knowledge is extracted from the user in-context natural language interactions within or cross dialogue sessions, and it's quite important to understand for understanding individual user preference. And second is incorporate external knowledge graph, which provide domain-specific background information and fuse with in-test knowledge, so that offer a more complete understanding of user semantics. And the third is about the emotion is about the synthesizing emotion insights. So which understand and express emotion leads to recommendation better aligned with user expectation, enhancing the user experience. So in particular, we found that the emotional insights play an important role in the conversational recommender system. So in our work on the published at RICSYS 2024, we relooked the conversational recommender system and proposed a new paradigm. We introduced the empathy within a conversational recommender system to bridge the gap between the system outputs and the user real-world need. As several output based on the current study on the conversational recommender system. So there are several key points. So first is to integration of the larger model into the conversational recommender system in the future work. So the larger model represent quite important, provide a quite insightful direction due to the larger model powerful language generation ability and extensive parameterized knowledge. And so based on that, there could be lots of potential future work that can be derived from the current SOTA study on the larger model to enhance the performance of the conversational recommender system. For example, the multi-agent based on some multi-agent larger models framework, and then about the human-centered conversational recommender system. So in our the recent study on the empathetic conversational recommender system, we provide several initial preliminary exploration about how to integrate the empathy with conversational recommender system. So actually there are more challenging settings for recommending multiple items in the conversational recommender system by integrating the empathy. And also, we see there is still lots of room to be explored for the human-centered conversational recommender system. For example, how would be the effect about the emotion in the conversational or affecting the results of the user's decision in the conversational recommendation procedure, and how can we protect the user privacy based on this persuasive response generated from the recommendation.
We are almost over time.
Yes.
Let
me briefly finish my talk. I think there is only one slide left. Okay, so that's my talk today. So thank you for attention. And we released the code and data for all the paper I introduced in our talk. Okay, thanks.
Thank you so much. Thanks for the very interesting talk. Okay, we are over time, but one of the students already told me that she has a question. So we'll get one quick question, then we conclude.
Thanks. Thanks for the great talk. I had a question about the LLM-based score for emotional intensity and the subjective metrics. How do you make sure that they align with the human? And when, for example, a large language model doesn't follow the instruction for the scoring, how do you handle those cases for better metrics?
Yeah, that's thanks for the question. That's really good. That's a very great question. So we also were asked by the reviewers and during from the feedback from the paper and also during the talk in the conference. So in what I only can say is in our work that probably on the RICSIS, we compare this consistency by using the human annotation. By hire 3 human annotators to annotate the part of the data and then compare the consistency between the human annotation and the annotation from the larger model. And then we found that okay, so in terms of several subjective evaluation metrics, we see there is a huge high consistency among these based on the results. So that is something we think that can be used as evidence to show that the GPT-4 larger model scholar based on GPT-4 could be used as a tool to annotate to grade the results, to evaluate the results or assess the results. But of course, there are lots of room to be explored in the future because we only checked several subjective evaluation metrics about the persuasiveness or logic persuasiveness or informativeness, which is a little bit biased or could be only partial part of the can be partially reflecting the performance. So I would say that in the future work there could be lots of room to be improved to double check if the consistency still exists between the human annotation and the larger model annotation. Especially, there are also can be some room can be enhanced based on our current work to double check if the trustworthiness provided by our proposed method still effective or especially compare with some real world or the ideal conversational recommendation scenario.
Thank you so much. I'm sure there are way more questions, but a lot of students have individual meetings with you, so they can ask their questions later.
Sure.
Thank Zhaochun one last time. Thank you all for joining and enjoy your holidays.
Thanks. Thank you for the invitation. Thank you for attention.